Hello everyone. We were continuing our chapter called Matter in Our Surrounding. In this chapter, we have already covered the physical state of matter like solid, liquid and gases. Then we have already gone through about what is evaporation and what are the factors which affect the evaporation. We have already completed. And in last class, we completed about the physical nature of the matter. So today we are going to cover the different properties of physical properties of matter, in which first we are going to cover what is diffusion is. Okay, what is diffusion is. Okay, see, diffusion means what? So diffusion is nothing but the intermixing of matter. Okay, or we can say matter intermixing. Okay, from the region of higher concentration to the region of lower concentration. Okay, what is mean by that? Suppose we have taken a glass of water here. Okay, here we have the glass of water and we have added salt here. Salt. Suppose we are taking NaCl, sodium chloride. So sodium chloride will go first on the bottom and will start dissolving in a solution. Okay, so that particles of NaCl will get distributed throughout the solution uniformly. It's not like that most of the particles will stay at the bottom and less will be on the surface. Not like that. All the particles of NaCl will distribute uniformly throughout the solution. This process is called as beta diffusion here. Okay, so when particles of the matter intermix on their own, so this process takes place on its own. Okay, hence it is called as diffusion. It's called as beta diffusion. I hope you understood what a diffusion is.
Yes, sir.
Yes, for example, we are going to understand one example here, like spreading of ink in water. Okay, so here we have taken ink now. So again, we're gonna have one glass of water here. Okay, and suppose I have taken the blue stain here, blue or blue ink in that water. So that water, okay, will dissolve complete blue stain in it. That means that blue stain.
That mixing, it will dissolve
Yes.
because of diffusion.
So, yes, so particle of that blue stain or blue ink will going to distribute uniformly throughout the water uniformly. Okay, and on its own, there is no external force is required for that. Hence, it is the diffusion. Okay, so during diffusion, the particles occupy interparticular space. That means all the particles of the blue stain here will occupy space between them, the perfect space between them. That means they are going to distribute uniformly throughout the solution. The rate of diffusion increases with increase in temperature due to increase in kinetic energy of the particles. Okay, if we will increase the temperature, particle will absorb more energy. So their energy level will increase, and due to increase in energy level, they will move fast. Their kinetic energy will increase, and due to increase in kinetic energy, they will spread, or their rate of diffusion will be faster. Okay, this is called as beta diffusion. Okay, can matter changes its state? Yes, if we will apply the heat due to rise in temperature, solid may convert into liquid and liquid may convert into gases. So yes, if you will apply the heat, then matter will change its state. Okay, so now we are going to understand the effect of temperature on the state of matter. Okay, very important and easy also. See how. Suppose here we have beta solid. We have solid. So we know solid particles have very compactly arranged and strongly bonded with each other. But if we will heat the solid, so particles of solid will gonna absorb energy, that heat energy that we are providing. So due to increase in energy, suppose I am just taking example of two particles. We are providing heat, so this particle will absorb energy. Due to absorption of energy, their energy level will going to increase, and due to increase in energy level, this particle will vibrate with their mean position like this. Okay, both particles will vibrate like this in all possible directions. Due to vibration, the bond working, the force of attraction working between these two particles become loose and finally gets breakdown. Okay, due to which solid converts into liquid now. Okay, if that bond becomes weak, then solid turns into liquid. On further heating, if we will further heat, okay, so on further heating, that bond breaks completely and particles get separates out and they start mixing into the air. That means liquid converts into gases now. Okay, so by increasing heat, solid may convert into liquid. On further heating, liquid may convert into gases. Sometimes solid directly convert into gases formed without going to liquid state. This process is called as sublimation.
For sublimation, sir.
Yeah, this process is called as sublimation. And conversion of solid to liquid is called as fusion. And liquid to gases conversion is called as evaporation or vaporization.
Yes, sir.
It is called as vaporization. If you will think like in a reverse manner, like when gases converts into liquid, it is called as condensation.
Condensation.
It is called as condensation.
So
When liquid converts into solid form, it is called as freezing.
freezing.
Freezing, sir.
Yes, and
Or
when
solidification.
yes, solidification also, and when gases directly convert into solid,
So
it is
that's
called
called solidification or sublimation.
it is called as deposition.
Yes, sir. Or solidification.
Okay, sir. So you're telling the phenomena of it, sir.
Yes, yes,
Above
yes.
you have written the process and down you're writing the phenomena of it.
So it's also called solidification, where gas into solid.
Maybe that solid is also going, like liquid is going to convert into solid. This is called as freezing, but it is also solidification. But deposition, we can say. Deposition is the process or name for that. Okay, everyone. So here we have gone through
All in sublimation only.
Yeah. So first we have fusion, conversion of solid to liquid. Then we have vaporization from liquid to gas, sublimation directly from solid to gaseous state.
Gas without
Yes.
going through the form of liquid
Yes.
state.
Gases to liquid is called as condensation. Gases to solid is called as deposition or solidification. Yes. And from liquid to solid is called as freezing. Okay. Yes. So these are the important 6 processes. It is nothing but the effect of heat. It is nothing but the effect of temperature, we can say. That means if we are going to remove the heat, okay, like this, means cooling. Okay, on cooling, gases converts into liquid. On further cooling, liquid converts
the
into.
particles come even closer and form solid.
Yes, yes. Okay, so this is all about the interconversion of matter from one state to another. Okay, everyone, any doubt here? If you have any doubt, you can ask the questions now.
No doubt, sir.
Okay, so now we are going to understand what is melting point is. Okay, suppose I have taken the ice. I have taken the ice. This is ice cube, and I have heated that ice. Okay, suppose we have this -2 degrees Celsius temperature of the ice. So when we have heated that ice at 0 degrees Celsius, at 0 degrees Celsius, that ice may start converting into liquid. Okay, so it is the temperature at which solid converts into liquid form. That temperature is called as beta melting point. And this melting point temperature is different for different matter. Maybe for ice it is different, for plastic, iron, whatever the matter we have, they are different.
Like the solids which have higher force of attraction have high melting points, like iron and all.
Yes, yes, yes. So their melting point depends on the force of attraction working between particles of the matter. Okay, if particles like matter, they are made up of the particles, they have strongly bonded, then melting point will be higher. If they are loosely bonded, then melting point will be low, like this. So what is melting point? We are going to understand from the notes now. The melting point of the solid is defined as the temperature at which solid converts into liquid form at a specific temperature. Okay. At atmospheric pressure is called, that temperature for the matter is called as melting point. So it is the temperature at which any solid substance get converts into liquid form. At a particular temperature at atmospheric pressure, that temperature is called as melting point. The melting point of two phases, okay, like solid and liquid, are the equilibrium. That means, suppose if you are discussing about the solid ice and the liquid water at 0 degrees Celsius, so that ice, okay, ice may present in solid form at 0 degrees Celsius, and at 0 degrees Celsius it may present in liquid form also. Okay, so here the phase transition takes place without change in temperature. So here they absorb the latent heat. Latent heat. So that 0 degrees Celsius temperature is the equilibrium temperature between solid and liquid. Understood, everyone?
Like the latent heat is like the temperature remains constant until
Yes,
the
yes,
state.
yes. Okay, that means the heat energy. We are going to understand first what is latent heating. So it is the heat required to convert the solid into gaseous form, solid into liquid form without change in temperature. That heat is called as latent heat. So at latent heat they may absorb or they may release, but temperature of that matter will remain constant here. Okay, so here we can say that ice at 0 degrees Celsius converts into water at 0 degrees Celsius.
So
Okay.
after the entire ice converts into water, then like the temperature
Yes,
will
after that
change.
temperature will gonna rise. Yes. Okay. So this is all about the melting point.
Sir, I didn't understand what is latent heat.
Okay, okay. Let me explain you here with the help of example. Wait a second. Suppose you have ice at your home. Ice, you know ice?
I have ice, sir.
Ice.
Ice only, sir, I have.
Yes, okay. Suppose you have ice, beta. Okay, and the temperature of your refrigerator is, suppose it is -5 degrees Celsius, and you have kept that ice on the at the room temperature at your room. Suppose that ice we have kept on the bowl here. Okay, and here temperature is room temperature means 25 degrees Celsius, but ice has temperature of -5 degrees Celsius. But after some time, temperature will gonna reduce and temperature will reach at 0 degrees Celsius. Is it or not?
Yes, sir.
So ice at 0 degrees Celsius, ice will start melting and will form water, water, and will form water. That time temperature will remains also same, which is 0 degrees Celsius. Understood that? But during the conversion of ice into water, temperature is remains constant, but heat energy is being absorbed. Okay, that heat energy is not going to change the temperature, but heat will
So it will
absorb.
change the state of matter.
Yes. So here we have changes. We have changed. See, water means the liquid. Huh? Water means the liquid. So here ice converts from solid to liquid state at 0 degrees Celsius. Is temperature is changing here?
No, sir.
No, na. That
Sir,
means.
no, sir, like time it will melt. After that, the water, even if ice is still left, the water will become normal, sir. It will still won't be in zero, no, sir.
Wait a second. Let me explain you with the help of that graph. Okay. Suppose here we have beta 0 degrees Celsius. Okay. Here 0 degrees Celsius. And here we have like ice. So ice, and here we have the heat energy, heat or state of matter. So here, like after absorbing heat, temperature will not going to rise. Okay. So here we have ice, and here we have water. Water means the liquid, and after that 0 degrees Celsius, temperature is going to rise up to 100 degrees Celsius. Okay, and after 100 degrees Celsius, that water will convert into gaseous form. Okay, so here temperature will remain constant, but here liquid converts into gaseous form, and here again temperature remains constant, and here ice was in solid and here water was at liquid state. So solid to liquid conversion here, it takes place without change in temperature. Okay, without change in temperature here, but heat energy is being absorbed. That heat energy is called as latent energy, latent heat of fusion. Yes, beta, you are saying something.
Also, like after every like solid molecule turns to water, then only the temperature will rise.
Yes. After some time, what happens? Whole ice will turn into water, and then water temperature will rise up to normal, like room temperature. Okay, everyone.
Heat only if solid converts into liquid in one temperature, or can it be liquid to gas also in one temperature?
Yes. The liquid to gas is called as latent heat of vaporization. Okay, and from ice to liquid means solid to liquid is called as latent heat of fusion. Okay, fusion and vaporization.
Sir, okay, sir.
We have latent heat. Later on, we will cover that concept also. We have in this chapter. Don't worry. Okay, so just do remember what is latent heat. The heat required to convert the solid into liquid state without change in temperature is called as latent heat. See, here we have the latent heat of fusion also, but first we have to complete that boiling point of the substance. Okay, so what is boiling point? Boiling point means it is the temperature at which liquid converts into gaseous form. Okay, it is the temperature at which liquid converts into gaseous form. That temperature is called as boiling point. Okay, and here again, like the temperature where liquid converts into gaseous form, here liquid and gases will present at equilibrium temperature. Suppose for water, if we are discussing about water, so at 100 degrees Celsius, water means H2O will remain at liquid state as well as at gaseous state. So that 100 degrees Celsius is called as equilibrium temperature between liquid and gases.
Sir, but like they will both like remain the same temperature, but the vapors will cause more severe burns.
See, after that, what will happen? If we are discussing about that liquid at 100 degrees Celsius, so 100 degrees Celsius plus latent heat of vaporization, then that substance will going to convert from liquid to gases. Okay?
Sir, in between your voice got cut off. Can you repeat?
See, at 100 degrees Celsius, water will present at liquid state. Okay, and after that, water will absorb latent heat of vaporization, and then liquid will convert into vapors.
Yes,
liquid
sir.
will turn into vapors. So here that latent heat is again, it is the required heat to convert liquid into gaseous form without change in temperature. Temperature will not going to change after absorbing latent heat. Okay, that means at 100 degrees Celsius itself, water will convert into gaseous form, but for that it has to absorb that latent heat.
So like, but it will cause more severe burns because of latent heating.
Yes, due to latent heat, solid converts into gases, gases convert into liquid form. And it is different for different matter.
Yes, sir.
Yes. Okay. Now we are going to understand latent heat of fusion. Latent heat of fusion. So it is the amount of heat, energy that required to change 1 kg of solid into liquid at atmospheric pressure as its melting point. Okay, its melting point means there is no change in temperature. So here we can say at atmospheric pressure without change in temperature. Here, instead of that, we can write without change in temperature is called as latent heat of fusion. Fusion means to melt. Fusion means to melt, and latent heat means that energy which is absorbed by the matter, but temperature will not going to change, but state will change from solid to liquid state. This is called as latent heat of fusion. Okay, so here I'm just going to draw one structure here so that you will understand properly. Suppose here we have ice. This is ice. Ice at 0 degrees Celsius. Temperature I'm writing here is 0 degrees Celsius. Ice will absorb latent heat of fusion and will convert into water. Water means at liquid state, but temperature will remain same. It is 0 degrees Celsius. And water is nothing but the liquid state, right? So here, ice converts into liquid means water without change in temperature. Temperature will remain same, but it is absorbing that amount of heat, which is called as latent heat of fusion. Now, we will further heat that water up to 100 degrees Celsius. So now I am writing 100 water at 100 degrees Celsius, and that water will absorb latent heat of vaporization, and then it will convert into gas. Okay, and that gas means vapor, and vapor will be at 100 degrees Celsius only. So here temperature is rising? No, it is remains constant, but latent heat of vaporization is going to absorb, will not going to change the temperature. Yes, will not going to change the temperature, but will change the state of matter from liquid to gaseous state. This is called as latent heat of vaporization. Understood, everyone?
Yes, sir.
Yes, sir.
Okay. Now we have sublimation. Again, very like simple. We have already gone through that. Sublimation is the process. It is nothing but the process of phenomenon in which solid directly converts into gaseous form. Solids directly convert into gaseous form without going to liquid state is called as sublimation. It's called as sublimation. Okay.
So like these are like very volatile. So they
Yes. Those substances, they are like volatile in nature. They may convert from like solid to liquid, or volatile substance means when any substance, maybe solid or liquid, converts from liquid or solid to gaseous state. All these substances are called as volatile. But here, like camphor, we are discussing about the camphor. We are discussing about naphthalene ball. Okay, all these are the substances which get sublimed.
Yes,
okay.
Like ammonium chloride.
Yes, ammonium chloride is also there. Okay, here we have example that even on your screen,
Sir?
it is ammonium chloride. Yes.
So what did you write below camphor?
Naphthalene ball.
Okay, sir.
Okay, so this is all about sublimation. Okay, so any doubt till here, Beta?